So what is the proof and how do we prove and how we're going to prove it or what? You're about to see. They're giving us a definition here, the fundamental theorem of calculus part 1. And they're telling us that the big F is equal to that. And they're like, okay, so I got some equation equals that. And then it's looking like a derivative. And they're saying that if I take a derivative of that function, as long as I have a variable x on the top and a constant a in the bottom, that it's always going to be equal to whatever I have on the inside, but you switch the t to an x. And at first you're thinking, yeah, it doesn't make sense. Like, I have no idea what any of this means. So here's the proof. And you're supposed to look at it and be like, oh, okay, I get it. Yeah, all that makes sense. Like, oh, yeah, I see it now. And you're supposed to get to like over here and be like, oh, what happens if C as H goes to 0? That's blah, 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 carries C belongs the wire, forcing C to approach. Oh, okay, yeah. Perfect. Did all that make sense to you guys? Okay. Yeah, I think that they think that you guys are math majors. And then they finally conclude, oh, okay, so the derivative of this integral from x to a of f of t dt is always f of x. We're going to do this with pictures. And you're going to see it's not that bad. It actually does make sense. So the derivative of whatever function I have in here, as long as I have the variable x at the top, who cares about that a? It does not matter. Will always be f of x. And I want you to think of this like, I know right now it probably doesn't make sense, but think of it like this. It's similar, the concept is similar to this. And I'm going to erase it in a little bit. Sine x plus 10. And I'm going to say g of x is equal to sine x plus. It's similar to this. Do both of these functions, f and g, have the same derivative? Yeah, they have the same derivative because when I take a derivative of a constant, it goes away. So the constant does not matter. You have the same derivative for f and g. It's similar to that. A is just some value. It's just some constant somewhere. And we're going to do it with pictures because I think you guys are very good with pictures. And I'm going to follow all this that they have with pictures. I give you the, okay, I did. Okay. So here we go. Let's start fresh. On the next page, we're going to start with that. So what do we know so far? We know that this means area under the curve, and it means area under the f of t curve. So I'm going to draw some function. I'm going to draw a curve, and they have an a there, and they have an x at the upper limit. And let's see, I'm going to draw dashed lines. And they're calling the area under this curve, they're calling it capital F of x. So that's the area under this curve. And that curve is the f of t. And that's it. That's all we know so far. How do we feel so far, guys? Nothing crazy, right? All right, so if f of x is this integral, I can say that f of x plus h is the integral from a to x plus h of f of t dt. Before I continue, let me make sure that you guys are okay with that. Can I say that? All I'm doing is mimicking. Guys, Travis, I have no idea what you're doing. All I'm doing is mimicking this. If I put a happy face here, then there's a happy face up here. So if I write on inside the expression, if I write inside here, if I write x plus h, then I write x plus h up here. Because they're telling me this is a function, and they're telling me there's an x, there's a function with respect to x, and there's my x. So if I write x plus h up there, then I write x plus h up here. Yes, same equation. So what does this one mean here on the right? Well, this one on the right means the same thing. F of t, a, and instead of saying x, I'm going to write x plus h. And that means this is f of x plus h. Have I lost anyone? Same thing. Ah. All right. So here we go. We're going to combine, let's see, should we? Yeah, we're going to combine both. And I'm going to go really slow, guys. Despacito, blah, 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 blah. That's, despacito stands for slow. Here's an X, and that is the X plus H. And I'm still looking at area under the curve I'm still looking at all this, which is just f of x plus h. So catch up to there. Okay, let's see if we can break this up. Can I say f of x plus h is the same thing as saying the integral from a to x of f of t dt plus the integral, where that one stops, this one begins, from x to x plus h of f of t dt. Can I say that? Okay, good. I see some nods. I think this is a nod. This is a shake, right? Or is this also a nod? Okay. So we just said, what did we say? Look at that. So this right here that I'm circling, that is just f of x, capital F of x. So I'm going to move it to the left. I'm going to subtract that. So f of x plus h, capital F, minus capital F of x equals the integral from x to x plus h of f of t dt. Catch up to there. What does that mean in terms of this picture? Well, f of x plus h is the area from a all the way to x plus h. F of x is just this area here in blue. Should I do it in blue? So if I'm subtracting, I'm only going to have this little sliver here in black. Well, man, it's not perfect, but that's fine. Do you guys agree that I'll just have that sliver there in black? Well, that sliver in black, and here it is, I'm trying to color code, is nothing more than h, and I can't put an equal sign actually, that's actually an approximate, unless I'm going to put an approximate, is nothing more than h times f of x. If I wanted, like, of course, that's an approximate because this really thing here is kind of curving upwards, so it's not perfect. But I can get it perfect. Hold on, don't worry, guys. So I'm going to rewrite out all this right here. So here's what I have. I have f of x plus h minus f of x is approximately h times f of x. That's that rectangle there. Now, if I divide by h, whatever you do to one side, you do to the other, it's starting to look like something. That's right. F of x plus h minus f of x all over h. But I don't want to approximate. So this is, okay, I'll approximate it here, but I'm going to erase it a little bit. At the moment, this is approximately f of x. But I don't want approximate. I want exact. Well, if h approaches 0, I will get an exact value for f of x. Right? So I can do this. Limit as h approaches 0 of f of x plus h, capital F of x, minus f of x all over h. And that is definitely going to equal f of x. Look what we just did, and some of you already realized it. This that I'm circling is just what? Not everyone at the same time.
Definition of a derivative.
Yeah, that's the definition of a derivative for which one? Capital F. Well, capital F was just this. So put simply, I can just write, let's see, put simply. So I'm going to put simply. What does that mean? It means this. d dx of this integral from a to x of f of t dt is just simply f of x. And don't worry, if you didn't understand any of that, you just got to know how to use it. But I would like for you to understand that. Isn't that kind of cool? All right, let's see. By the way, what is this called? Fundamental Theorem of Calculus Part 1. FTOC 1. Okay, how do we use it? All right, Chavez, how do we use it? Like this, guys. I'm taking the derivative. Look at letter A. I'm taking the derivative. Do I have a constant in the bottom? Yes. Do I have a variable x in the top? All this right here just equals cosine x. Done. That's it. Yeah, that's it. I just took the derivative. I'm just doing this rule. I'm just doing this rule right here. I took the derivative of that integrand. As long as I have a variable x at the top. And we proved it too with images, with pictures, that we just still get that we, look, the derivative of that integrand is just f of x.
Oh, so it's saying the derivative of the area under the curve of this?
Well, just the, no, the derivative of the integrand, which is area under that curve of that, will just be your f of x value. The derivative of the integrand is just what you have inside itself. So let's see. Let's try this one, guys. Do I have a constant in the bottom? It doesn't even matter what constant. Do I have a constant in the bottom? I do. Do I have a variable at the top? I do. So the derivative of that expression is 1 over 1 plus x squared. If the bottom is bothering you, like, oh man, Chavez, it's bothering me that it doesn't matter what constant it is. That's because, remember, you guys told me a little while ago. Oh, I already erased it. I thought I still had it here. I told you this a while ago. F of x equals sine x plus 1. G of x equals sine x plus 100. Look, those differ. That's a 1, that's a 100. They differ by 99. It's a different constant. But do they both have the same derivative? Yes. So if it's bothering you, like, oh, it's bothering me that I'm taking the derivative of this integrand and that constant doesn't matter what it is. As long as it's a constant, it does not matter. It goes away when we take the derivative. Cool? Okay, let's continue. Look at this one here. This one has chain rule. Chavez, how do they have chain rule? I'm taking the derivative. The top expression needs to be an x. This is an x squared. So as soon as there's an x squared, I'm doing chain rule. So here's how you take the derivative. I'm going to say y prime, because they're telling me why is that. Y prime, I have a constant on the bottom. That's good. So when I take the derivative, I write cosine. Whatever the expression is for t, you're going to substitute the whole expression there. Cosine of x squared. And then I'm going to multiply by the derivative of x squared. And there it is, guys. So y prime is 2x cosine x squared, and you're done. Cool or not cool?
That one? Oh, could you explain that one?
Yes. The definition is d dx, a constant in the bottom, and I have to have an x on the top. This is the definition. So if I take the derivative of that, that's f of x. But you have to have an x. This is not an x. This is an x squared. So as soon as I write anything besides x squared, x whatever, I have to do chain rule. So I replace the t, whatever expression you have in there, you're going to replace it with the variable up here. I replace the t with an x squared, and I just took the derivative of just that top component, 2x. And we're going to do some more, guys. Don't worry. We're not going to set you high and dry. Look at example 3.
Wait, Mr. Chavez.
Yes, ma'am.
If that was like an x cubed, then would you have to do cosine of x cubed times 3x squared times...
No, that's it. You just do it one time.
Okay.
Does that make sense? Perfect. All right, example 3. You got to have a constant at the bottom and an x at the top. Can I take the derivative immediately on example 3a? No, you got to use your properties. Before you do anything, rewrite it. Y equals, if I switch your limits on the integrand, what happens on the outside of the integrand?
Negative.
Negative. So put a 5 in the bottom, x at the top, 3t sine t dt. Now I'm ready. I'm going to take the derivative. I write y prime, leave the negative alone on the outside. On the inside, whatever has an x, put an whatever has a t, put an x. 3x sine x. Done. Actually, you don't even need parentheses, but I wrote parentheses in there, so too bad. And that's it. You're done. Uh-oh, look at the bottom. Look at letter B. Don't worry, guys. We're going to talk about it. Do I have a constant at the bottom? No. Break it up into two integrals like this. I'm going to break this up into, the lower limit has to be 2x. And I would use a letter to indicate a constant. So I would say a. And on the side, I would put a as a constant. Of 1 over 2 plus e to the t dt. Plus, wherever this integral stops, the other one better start. A to x squared of 1 over 2 plus e to the t dt. I'm almost ready. This integrand is ready to take a derivative. I guess I'll put a check mark there. But this one is not. All I got to do is do what? Yeah, just flip the limits. So here it is. When I flip the limits, put a negative integral a to 2x. So both of them you're going to have to do chain rule on both. And it's really simple, guys. So here we go. And I'll slow down. That is equal to y. Y equals that. So y prime, I'm taking a derivative, equals negative 1 over 2 plus e to the 2x times 2. I'll fix it in a little bit. Why did I do times 2? Because the derivative of 2x is 2. And you're done with that. Plus 1 over 2 plus e to the x squared, because that says t, times, what's the derivative of x squared? 2x. If you check the answer in back of the book, well, this one came from a book. It would have been, let's see, they would have told you 2x over 2 plus e to the x squared minus 1 over, oh, that's a 2 now. 2 over 2 plus e to the 2x, and leave it alone right there. You could actually leave it alone here as well too, but you might not see that answer as a multiple choice. How do we feel? Do we feel okay, guys? The day that I get observed, I need you guys to all unmute at the same time. You're like, yeah, 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 yeah. I mean, well, I don't know. Maybe start making it a habit. Unmute and say, hell yeah. Or don't say hell yeah. Oh, yeah. Yeah, Kana's really good at doing that. Maybe you can do it on the day of the observation. Okay, never mind. So here we go. The fundamental theorem of calculus part 2. We're not going to do a proof of this one, but if you want to see a proof, maybe we'll do one after school. It's not as nice as the first one. The first one is like, oh yeah, that's pretty cool. I thought the first one was cool. The second one is kind of like a cop-out. They replace F, big capital F with a G, and then they're like, okay, big G means F. And yeah, it's not as good as that one. So I'm just giving you the formula and theorem 4. Obviously, I took that from a book, right? So here's the formula. Big F stands for antiderivative. Here's how the book wrote it. Wait, was that proper English? Here's how the book wrote it. I do not like the textbook. I mean, I do, but I don't. I think they think that every single person that reads this textbook is a math major. What does this mean? Well, they do tell you that F is an antiderivative, but in case you get confused, it means this. I don't know which one you like better. Do you guys like number 1 better or number 2? Look, I just put numbers on them. I think number 2 is easier, but I don't know. Mazuka, do you like number 1 better?
Yeah, I like number 1 better.
Oh, I see. Haters gotta hate. I'm kidding, miss. I promise that was a joke. Yeah, so they're telling us capital F is an antiderivative. All they mean is this. That's all they mean. So, example 4, we haven't done the quote-unquote official proof. If you want to see the proof, maybe swing by after school. It doesn't take that long, but I just don't think it's a very good one. It's kind of like a cop-out. So here we go. They want me to solve this with antiderivatives. Well, according to my rule up here, I want to see it. According to my rule up here, it's telling me to take antiderivative, plug in the top, antiderivative, plug in the bottom. So let's do that first. I'm going to find the antiderivative. So I'm going to write integral -1 to 3 of x cubed plus 1. I'm just rewriting it, guys. Antiderivative of x cubed is x to the 4th over 4. Antiderivative of 1 is just x. Because I have 2 terms, I like to put like a bracket on both ends like that. On the bottom end of the right-hand bracket, I put a -1. On the top, I put a 3. And that means that I'm going to evaluate it at those values. And I'm just following rule number 2 or rule number 1 if you're following Mazuka. And you're doing upper minus lower. I'm not throwing shade, Mazuka, I promise. And I'm just going to go 3 to the 4th over 4 plus 3 minus -1 to the 4th over 4 plus -1. On the AP exam, you can actually leave it like that, but professors hate it. They're going to be throwing so much shade at you, like crazy amounts of shade. So I don't want to hear all that shade from them. So I recommend that you go ahead and simplify. But if you are scared, but no one's scared here at YWLA, right? But if you are scared, you can leave it alone if it's free response. But if you're not scared, well, I said, if you're scared, you can leave it right there. But I would prefer that you continue, guys. I really would. It's only worth 1 point, the answer anyways. Let's see, 3 to the 4th. Have we done this one before? Okay, what do we get as an answer? Okay, we have done it before on the last notes. Last notes. Did we explain it like this or did we explain it differently? We explained it the same, right? All right, there is a way to do it in the calculator. Let's pause for that. Let's just chat real quick about it, guys. If you always use your calculator, if you're using your calculator all the time, 60% of the AP exam is without a calculator. So try to get on the habit of doing everything first without a calculator. Which questions are going to be the ones that you're going to be able to use the calculator? If it's something that is really hard to integrate, if it's something that you've never covered, and they're like, man, I don't know how to integrate that, that is when we use a calculator. So if it's something that's really hard to integrate, we use the calculator. If not, do it without a calculator first. Cool, guys? Okay. Don't worry, we're eventually gonna teach you how to do it with a calculator. Really, it's really simple, guys. If you already have a calculator, you can just play with it. So let's go to this question. I'm really excited about this one. I'm actually super excited on this one. Ms. McLaren, are you here? Okay. She's not here yet, guys. But if she were here, she would be really happy. And hello, Ms. McLaren, if you're watching this video right now. Okay, because you never know, right? Anyways, let's continue here. So it says using the graph of f to analyze. So they tell you h of x equals this fancy integral a to x of f of t dt, and you're thinking like, man, that's weird. Why do they have a equation with an integral? Well, we're in 2021, and nowadays we have computers, and we can make an equation equal to any expression. So this equation equals the integrand from a to x of f of t dt. And it says the graph of a continuous function f with domain 0 to 8 is shown to the right. So this graph, before you even start, label it. This is f. If you want to write f of x, that is fine. It's not a big deal. Remember, that's a dummy variable, so it doesn't matter f of t, f of x, f of g, f of u. It does not matter. I'm just going to put f then. And it says, let h be the function defined by, and again, they tell us they're nice, and they're telling us what h is defined. Letter A, find h of 1. Well, h of 1 just means wherever there's an x, plug in a 1. Integral 1 to 1 of f of t dt. What is that?
0?
Yeah, good job. 0. It's 0, guys. I don't recommend you put a happy face or smiley face in the zeros on the AP exam. Just put 0. I mean, I guess if I were grading this AP exam, I would probably like chuckle. Ha ha, this kid, he's funny. And then give him the point. I guess that's fine if you want to make the reader laugh. All right, next question. Oh, ask. Okay, the question was any integral that has the same two numbers as the limit, top and the bottom, will it always be 0? And the answer to that question is absolutely yes, always. Why? Because you haven't moved. H of x of this integral literally just means area under this curve. Under this exact curve, the f curve. And if it says 1 in the bottom and a 1 in the top, well, you're just stuck right here. You haven't moved anywhere. You know what I mean? Good question, miss. Okay, next one. Is h of 0 positive or negative? Justify your answer. So I'm going to go h of 0 equals integral from 1 to 0 of f of t dt. And I don't have an equation for this curve. They don't tell me that's a semicircle, so there's no way I can calculate it at the moment. All I care about is it positive or is it negative? Look where you're starting. You start at 1 and you end at 0. Because you're starting at 1 and you end at 0, am I counting backwards? So this is going to be negative because you're like counting backwards. Chavez, the area is above the x-axis. That's right. But you're counting backwards. So negative times, a positive times a negative is a negative. Does that make sense to everyone? Okay. What if, okay, time out. What if that area was below the x-axis? Then it would be positive because negative times a negative is a positive. Are we all in agreement there? Okay. All right, next one. Letter C, find the value of x for which h of x is the maximum on the open interval 0 to 8. Guys, the rules still apply for max and mins. They're not talking about max for f. This is f. If that were the case, maximum happens at 3. They're talking about max of h. Do I know how h looks like? No, but I can figure it out. What's the rule for max? Where what changes from what to what? Okay, Godina's answered it. She goes where the first derivative goes from positive to negative. Does everyone agree with that statement, guys? Perfect. Well, I have a function h. And so here we go. I'm going to write my function first. H of x equals integral from 1 to x of f of t dt. I'm going to take my derivative. Do I have a constant in the bottom?
Yes.
Do I have a variable at the top?
Yes.
Perfect. H prime of x equals f of x. Oops, that x looks like a t. There it is. This graph is f, which means it is also h prime. So now you can go up there and call that h prime. Now, where does your h prime, which equals f, change from positive to negative?
At 3.
No, not at 3.
Oh, at 4.
At 4. So here's what you're going to write, guys. You're going to write maximum maximum occurs at x equals 4 since h prime, which equals f, is changing from positive to negative at x equals 4. And I know it sounds silly saying it again, but say it again. Max occurs at x equals 4 since h prime, which equals f, is changing from positive to negative at x equals 4. Done. Letter D. Oh, what's up?
I have a question about B. Like, say this were an F or Q, could we say, like, it's negative because you're counting backwards? Or would they,
if they ask you to justify, yeah, that would be perfect. It's negative because I'm starting at 1 and ending at 0. And my area is above the x-axis, hence negative. You can also say, quote unquote, counting backwards, and I think that will be full credit. Okay. Letter D. Find the x coordinates of all points of inflection on the graph of y equals h of x. Well, same thing, guys. Where do I have a point of inflection? Give me the definition first. Someone besides Godinez.
where the six?
Go for it, Vieja.
No, you can go. It's fine.
Okay, I was gonna say when the original graph changes concavity.
Okay, but how do I know that? That is when I have a point of inflection. But how do I know it with calculus? There's two ways. You guys know this, guys. Oh, man. Ms. Gonzalez?
When it changes from increasing to decreasing?
When what changes from increasing to decreasing?
Huh?
When what changes from increasing to decreasing?
H prime?
Yeah, you can say that. You can say that. There's two definitions, guys. I'm going to write them here on the side. You can say either where H prime changes from increasing to decreasing, or vice versa. Actually, there's three that you can do. What's the second one that I can say? Instead of H prime, what else can I say? Tell me something about the second derivative of H. Or H prime prime.
0 or undefined?
No, better than that. You're right, 0 undefined, but H prime prime changes signs. And I guess there's one more. If H prime changes from increasing to decreasing, I guess you can say H prime has max or min. But I wouldn't use this one. I would use these two. So let's look at H prime. Here's H prime, guys. So I'm looking at H prime, and I see that H prime is changing from decreasing to increasing at 1. And then I'm changing from increasing to decreasing at 3. And then one more. What's that one more, Ms. Godinez? Perfect. So I'm going to say y equals h of x has points of inflection at x equals 1, 3, and 6, since h prime, which equals f, is changing from, and I always like to do the first one first, from decreasing to increasing, and vice versa at those specific x values. There it is. And I decided to use h prime, which equals f, because that is the graph that they gave me. Does that make sense? You could have also said h prime prime, changes signs at those, because they do. But the best answer is to use the graph they gave you. The worst answer is to say points of inflection at 1, 3, and 6 because the graph of h changes concavity. Well, that's what they're asking for. How do you know, though? Like, how do you know? You're not telling me anything. You just told me that h changes concavity, but we don't know any reason why. Like, why? So, cool. All right, guys, let me come back. You guys are already back, so